Initially, for example, if you take the electric vehicles, they're actually mostly considered as a problem because it's a big load and it comes often at the same time and not necessarily always when you want it, if you see it from the grid perspective. But it has a huge flexibility. People plug it in at night and they don't need it until the next morning. So you can shift it several hours and you can turn it on and off. And it really gives you a huge kind of flexibility to put into the system.
Welcome to In Between Charges, the perfect podcast to listen to whilst waiting for your EV to charge. As always, I'm joined by my co-host, Kevin. Welcome to the episode today. How was your lunch? We're feeling a little bit tired after some heavy potatoes and some vegan frikadelle.
I'm also tired because I'm on cough medicine as well, so that's putting me to sleep. But couldn't be more excited for this conversation today.
Fantastic. Good. And if you do hear the sound of rumbling noises in the background, it's not the building falling down. We are having our windows replaced within the structure.
And they chose our specific corner of the building to work on at this very recording hour. So thoughtful of them, but we're going to power through.
They did. Our podcast is so popular, they chose to specifically drill and take out windows at this area.
We're going to power through the power drills.
Okay, great. In this episode, we are joined by Andreas Barnekov Thingvad. Andreas is an expert in energy storage and energy trading at Hybrid Greentech. Incidentally, the first podcast episode that we ever recorded was with Christopher, also from Hybrid Greentech. And Andreas is one of Denmark's rising young talents, selected as one of the top 100 young talents in Danish business. He holds a PhD from the Across Continent's Electric Vehicle Services Project, where he focused on the role electric vehicles can play when integrated into global power systems. So very relevant for the work that we do here at Monta and also for electrification of transportation. I think it's fair to say that if anybody knows anything about how the grid is currently and can adapt to electrification, Andreas is the man for that. Welcome to the show.
Thanks a lot. Honored to be here.
So maybe starting question, just to understand a little bit more about your background. What is it and how did you first become interested in the energy industry?
Yeah, I actually wanted to make robots and studying automation at the Technical University of Denmark. And then I ended up doing my internship at the National Laboratory for Renewable Energy, where I was asked to develop this testing device for electric vehicle chargers and making sure that they followed the standards. And then I just saw a lot of potential for automation and ended up working on doing all kinds of grid services from my bachelor and from my master and then into the PhD and continued ever since.
Wow. So the industry must have changed quite a lot since you did that, right? I guess before you mentioned trying to make sure a charge point was compliant with standards. I mean, did standards even exist back then?
Yeah, I mean, you had the first version where you have the PVM signal that had come out, but I remember that I knew all the EV brands you could buy in Denmark. It was like 3.
3 of them. Wow. I think now we have almost 250 different models now integrated to Monta, maybe more, 400 plus.
400, I think, from like 130 brands or something like that.
Yeah, so, exactly.
And we love them all, right? They all work perfectly, no problems.
Exactly. All of them implemented OCPP at the same level of standard. But anyway, charge points aside, not to get too kind of taken aback by that, because that is what Kevin and I live and breathe every single day here at Monta. What we want to talk about today is the energy market itself. And really, I think, understand, Andreas, from your extensive background and also the work that you're doing at the moment, how the energy market will and maybe needs to evolve into the future. Not just in next year, but also looking up to 2030, 2035, particularly as countries start to hit their ZEV goals, hopefully, and also in the face of pretty significant disruption from various sectors. I think we talk about it a fair bit. So electrification of transportation, for example, estimations are that power demand will grow by 14% year on year as the result of the rollout of electrification of vehicles, heavy-duty vehicles, but also charging infrastructure. The renewable energy introduction en masse. So there are some reports that suggest that by 2035, renewable energy will account for about 60% of installed capacity as opposed to 35%. And hopefully that is done in parallel with a phase out of things like coal and other fossil fuel energy resources as well. The list goes on. And I think to understand where we need to go and how the market could evolve, we need to know a little bit about where we stand today.
I mean, it's actually an incredibly old system. You have the household with the electricity meter. They have a spot price agreement nowadays is the most common with a retailer, and the retailer then has a spot price agreement with the balanced responsible party. But then the balanced responsible party will go into the energy markets, which is the day ahead at 12 o'clock. And that also sounds a bit crazy when you think about renewables fluctuating like from hour to hour. But that's because it's a more than 30-year-old system and you need to make your bidding by fax and it had to be during the working hours. And that's still the way we do it.
Bidding by fax?
Yeah, I mean, that's how it was, and that's the reason it's at 12 the day before. I mean, now we do it automatically over the internet, but it's still that legacy system where everyone has a price setting of that single auction that happens the day before.
Wow.
So then I would put all the forecasted production and consumption into the market, and everyone else does the same, and then they basically choose the cheapest resources to supply the demand.
But that's how it works in Denmark? Is that how it works in all of Scandinavia or the Nordics? Or
it's all of Europe.
All of Europe,
yeah. There are some places, like back in the old days, it was kind of central dispatch, so you had the transmission system operator deciding who should produce what to create the cheapest solution for the society. So it's actually much more simple, or it's a kind of already distributed that people tell the market what do they need, and then it's just cleared and everyone gets the same price.
Okay. But when you say people tell the market what they need,
that's the BRPs, balance responsible parties.
Okay.
Yeah. And then probably some of the production is going to produce something else than what expected the day before, or the consumption is going to be different. Then you have some choices to trade yourself into balance in the intraday market. But in principle, it is actually to trade yourself into balance. So during operation, Energinet will see, oh shit, we need 100 megawatt extra. And then they start buying directly from the producers. And then some of them are cheap, so if they don't need so much, it's going to be cheap to produce some extra. But if they need a lot, it's going to be more and more expensive, and sometimes it's just going to be 10 kroner per kilowatt hour or some crazy expensive. Previously, people haven't reacted to spot prices at all, but now you get negative prices and people start disconnecting their PV, like pulling it out of the plug because they don't want to produce when they're paying to get rid of it. And then suddenly it's really difficult to forecast.
This is a new phenomenon that might be interesting to go into a little bit more detail. What is it that actually creates negative prices? Because for the consumer, it's great because it means you can basically get paid to consume electricity, but that seems counterproductive for the whole business model of the energy market.
Yeah, but you could say it's counterintuitive that it even happens. But a lot of PV was actually installed without any control. So they had to produce. So you kind of had to sell it at negative price, because if you didn't sell it, then you would have an imbalance, and that could be 10 times as bad. The interesting thing about the balancing price is that previously they had this two-price system where you would always get the spot price or worse for your imbalance. But now they transition to this single price system where all your imbalance is at the imbalance price. And that means that you might, if you have too much and there is too little in the grid, then you're actually getting a higher price for that difference. So that means it's equally likely that you are earning money from it as losing money. So sometimes it's actually incentivized that you have an imbalance as long as you're helping the grid, because then it doesn't matter what your traded position was. If the grid needs electricity and you can deliver it, then you're being rewarded for it.
Okay, so the logic there is, let me break it down. So there's the supply side, and they are generating energy from various different fuel sources, and that's being passed into the transmission system operator, who are the usually countrywide or perhaps regional if countries divide their TSO system into two or more. And then the TSOs are setting the price at that first intersection between supply to TSO. Is that right?
First, the price is set by it's called the Nominated Electricity Market Operator, or NEMO. And that price kind of becomes the reference price for everyone, or every single spot price deal in all of Europe.
Yeah.
And then afterwards, you could say it's kind of a financial thing because it's about what you traded. It doesn't matter what you delivered. But then when you come to the delivery, they will look at what you actually delivered and compare it with what you traded. And that is the difference, is the imbalance price. And again, it will make sure to buy enough to cover your imbalances. And it's like in the day-ahead market, the lowest the price can go is minus 500 euros. But in the imbalance prices market, it's like 10,000 euros. So yeah, you can earn money from the imbalance market, but it's also a huge risk.
And this power is coming from, you said, various different fuel sources, but there's a lot of wind power in Denmark, right? There's some solar. I don't know how much, but when I hear about blackouts or failures right now, oftentimes, or utilities needing to keep a higher capacity online to meet the demands when there's a surge and everything. But what's the modern day equivalent of that a little bit in a grid that has a lot of renewables that are kind of continually there? Is it pulling it from the battery storage? How are these kind of markets working with linking the actual source of the power to the end consumer?
Yeah, so actually, when you have the day-ahead market, it's hourly, and everything is on an hourly basis. But the crazy thing is that there is no kind of buffer in the grid. What you produce and what you consume needs to be exactly the same on every single second. So that means when you turn on your electric kettle at home, there is a power plant increasing the production to match that. And Energinet and the other TSOs are buying primary reserves to make sure that the instantaneous 1 second imbalance, the tiny fluctuations, are met. Because if they're not met, then like after a few seconds, there will be a blackout. But that's called the primary reserves, and that's the things that are super nice to make with the EVs because it's rare. Yeah, like you just have to turn them up a little bit. You don't have to have like long breaks. It's more the capacity, and the electric vehicles have a lot of capacity. But people complain if you turn them off for several hours until the wind starts blowing again, for example.
But you typically don't need it for several hours at a time. You might just need it for 10, 30 seconds.
Yeah, exactly. But then you have the secondary reserve, which is, so first, if you have, for example, a nuclear power plant in Sweden having a failure, which happens every couple of months, then you have the super fast response of 30 seconds, and that could be the electric vehicles turning all of them off, and then you can meet that deficit of production by turning off all the EVs. But then after 30 seconds, then you have some slower, maybe biomass, combined heat and power plants increasing their consumption. And then you go into the secondary reserve where you have the big and heavy power plants that are slower at ramping up, but then can deliver serious bulk energy.
Okay. So that's a pretty good view about the current state structure. And I think it's fair to say it's complex. But there are conditions in place to make sure that there is a constant supply of energy to both commercial, industrial, and then also residential users. You mentioned the example of a kettle. So all the way through from second by second fluctuations through to actual big seasonal fluctuations, or maybe in hours as well. And we know in the UK, they introduced a smart charging regulation that basically tries to disincentivize people from charging between 8 to 11 a.m. and then between, I think it was like 4 p.m. and 10 p.m. because that's when everybody's turning on their washing machines. They're starting to cook on their electric hobs because a lot more people have that now.
Drink a lot of tea in the UK.
Drink a lot of tea, and there's a lot of kettles going on.
Yeah, you can actually see frequency drops in the break when you have the big football matches on the national level because everyone goes out, turn on the kettle in the break.
Yeah.
So you can see that on the national frequency.
Yeah. Wow.
But even the EVs are also becoming, just in Denmark, it's like more than 200 megawatt. So it's like when they're peaking because they're all charging at the same time after midnight.
So with the current structure, it sounds pretty thorough and well thought through. So you have the balancing market, you have day ahead, intraday, and then essentially more of the quicker response markets if you need to purchase additional capacity, maybe even the hour ahead before. And then you also have reserves where companies can purchase, again, maybe outside of those trading hours to try to increase the capacity if they need to. I mean, what are some of the problems that are now coming up as a result of renewable energy, electrification of transportation, etc.?
Yeah, I mean, it is a well-functioning system. I think we're going to need more reserves. But then all the primary reserves, they are dimensioned based on the biggest singular fault that can happen in the grid. And even though we get a lot of wind turbines and solar parks, then that's still going to be the 1.4 gigawatt nuclear power plant in Sweden, because a lot of small distributed units doesn't create a bigger singular fault. But it creates a lot more potential lack of energy, because suddenly there can be a cloud and then they're not producing anything. And like that can happen on a big area, and suddenly you need to deliver several hundred megawatt hours to kind of put the grid back in order. But that is exactly what the TSOs, the transmission system operators, are handling via these MFR markets. I think.
It's hard to talk about it without the acronyms, right? Because otherwise...
Yeah, so the secondary reserves is the one that are going to grow proportional to the green transition. So that's also why it's super interesting you would say the primary reserves are large, but it's kind of a limited market. It's not growing that much, and you're getting a lot of battery storage that are delivering these services all the time because they don't have to do much. They just have to be ready for more fluctuation.
Maybe then I can rephrase as well part of it. So what are some of the biggest problems or the biggest points of failure for renewables to really come into the market in earnest and for us to be able to actually maximize capacity?
One thing that has changed in the market size is that now on a European scale, they're introducing intraday auctions. So instead of intraday, it's actually continuous, like a stock market. You can buy 1 megawatt hour here at this price, going back and forth. But now they will have like a centrally cleared auctions like the day ahead market, where everyone can bid at the same hours. That is a way to get closer to the delivery hour, basically. So it becomes easier to balance yourself out.
And you mean the closer you can be to your consumption amount, basically, the better your forecast?
Yeah, to when you need to deliver it.
Yes.
Yes. Exactly. The other TSOs has also started including geotags in their reserves, in the secondary reserve, which means they can see where it's being delivered from, because that enables them to handle kind of bottlenecks. Like, for example, we already have problems with too much solar production down in Lolland or in Bornholm. And then they can say, oh, I want to buy some downregulation from that area. Because the renewables are not producing all the time, then you kind of need to have an overproduction.
At other times.
Yeah, exactly. And that means that you're going to have way too much in a specific area sometimes. Then you're not able to lead it away. And you end up having someone paying a super high spot price in the other end of Norway, for example, and having a super low price in the other opposite end. Because you cannot get the electricity to where you actually need it.
Yeah, I think that happens also quite a lot in Switzerland. It can vary by a factor of 5x depending on which canton you sit in. We mentioned already there's a ton of disruption coming into the energy market. It's happening now. It will continue to happen up to 2040, 2050 until renewables have been completely phased in. The adoption of EVs are also perhaps more widespread and a little bit more stable. I guess in some of the problems that you highlighted, what are some of the things that you, from your experience, your research, and also your role at Hybrid Greentech, what kind of are some of the solutions that are needed in a future state grid structure to be able to solve some of those problems?
Well, that's a good question. We have kind of started with the primary reserves because when you have like electric vehicles or electric boilers or batteries, you have a lot of power capacity, but you cannot supply it for so long. So there you can get a really good value for the customers or owners of these assets. But then you need to move into the kind of the slower reserves to kind of help with balancing the grid with the green transition and the bigger bulk imbalances you're going to get. So I think that's the way we are moving, being able to kind of take a bigger responsibility and making sure that there is enough electricity in the plug, basically.
So let's maybe talk about the ways that you and Hybrid Greentech, the role you play in those primary reserves and how you kind of actually operationalize that a little bit, right? So I think one of the things you have, I'm sure there's a few others, but is a virtual power plant, right, is what Hybrid Greentech does. And I've got two quotes I wanted to read here, and then I'll tee you up to kind of explain it a little bit. But you hear a slogan, I forget to attribute this to, but they say there's no transition without transmission is something you hear, right? Yeah. And we know the transmission issues that are rampant in Europe and America, right? There's big, long queues to actually hook everything up. And then there was another, I was reading something the other day and said, this was a manager of a utility in Texas, actually, said, you can call it VPP or load flexibility or flex demand or demand response. You can call it home batteries. Doesn't matter to me. Here's what I call it. When I don't have enough real power plants supplying power to meet my demand, I've got to figure out everything that I can do. So could you talk about what that virtual power plant is and that key role it plays in activating those primary reserves and how that can be a workaround maybe to all of this transmission that is needed in the future?
Yeah, I mean, initially, for example, if you take the electric vehicles, they're actually mostly considered as a problem because it's a big load and it comes often at the same time and not necessarily always when you want it, if you see it from the grid perspective. But it has a huge flexibility. People plug it in at night and they don't need it until the next morning. So you can shift it several hours and you can turn it on and off. And it really gives you a huge kind of flexibility to put into the system. I would say the politicians mostly talk about hydrogen and power to X and this.
Don't mention hydrogen to
magic.
Kevin. It's going to kick him off on another coughing fit in a minute.
As a kind of magic silver bullet to handle all the problems, because it is a problem that you don't have the production when you need it and it's not going to match your inflexible consumption. Yeah. But it's just so incredibly inefficient. While if you have the electric vehicles, they are just super efficient. And the political target is 1 million EVs in 2030, but it looks more like we're going to reach 1.5 million by then. And then they have like...
in Denmark, you mean?
Just in Denmark, yeah. 60 kilowatt hours each, and maybe they need to charge 10 kilowatt hours per day in average. Yeah. So just shifting that around, like it's more than the entire residential demand.
So then what is Hybrid Greentech doing in that? Or how do you exactly play in that and help that solution thanks to EVs and other connected assets?
Yeah, so Hybrid Greentech is a balanced responsible party, so we are trading in all the markets. And then we're also an aggregator and controlling the electric vehicles. And basically, it's a capacity market, the primary reserve. So you forecast the capacity and then you bid it into the market and say, I have 50 megawatt at night, for example, and 10 megawatt during the day that I want to sell as a backup. It helps pushing out some of the CO2-heavy production, but it's actually a much better response because you can turn off all the vehicles in parallel, so you can go from 0 to 100 in a few seconds, while a coal power plant takes 5 minutes to do the same thing.
So you're a software solution that can do what a coal plant can do in half a second or a few seconds, what a coal plant would take hours to do or days to do?
Yeah, exactly. And so we measure the frequency of the grid. So we are paid for the availability, and then we measure the frequency ourselves 5 times per second. And then we see before any other communication have time to arrive, we have already detected that the frequency has dropped, something is off, so we need to activate the electric vehicles or the boilers or the batteries. So everything just happens within like 200 milliseconds.
And then maybe the other part related to that, we talked a little bit just outside this beforehand about vehicle to grid. That was also a project that you worked on to begin with. There's a lot of discussion about vehicle to grid. Maybe it's related to virtual power plants because it means charging can then go both ways. And it's not just about starting and stopping. It is also about the transmission of electrons from the vehicle into the grid, not just to balance, but also create a new market. I mean, can you talk to us a little bit about vehicle to grid, and is the hype going to deliver against that kind of promise? Is that something that you see coming up as another mechanism in the future?
You can say it's actually weird it's not here already because it's a pretty simple setup. Like the battery is DC, and when you have a fast charger or DC charger, then you're basically connecting directly to the terminals of the battery. So if you have a bidirectional charger, like you can build a bidirectional inverter and then you can discharge it again. There's nothing really super fancy about that. But actually, in my research project, it was with Nissan's vehicles, and they already had, because they were the biggest EV producer in the world.
The Leaf. And then
the popular
don't hear
Nissan
about the
Leaf.
Leaf a whole lot more anymore.
It's been going back a bit for them. But actually, they developed the first DC charging standard, which was V2G compatible. And then they tried to spread it out to the European market and talking to the German OEMs. And then the German OEMs were like, maybe it's better to make some kind of trade barriers here. And then they developed their own standard. And that's basically not been able to do V2G for like 10 years later. It's still not ready. So that it's actually the whole standardization of the DC charging plug that is standing in the way.
Okay, so that was it. So if it's so easy, why hasn't it become something that's used now?
Yeah, I think the German OEMs are actually working on it right now. So it actually looks like a lot of work is being put into these working groups at the moment. So I think it is actually going to happen maybe in a year or so. And that is going to change everything. With V2G, you can kind of keep it at zero, and then you can offer both charging and discharging every hour that you're connected. So instead of having 1 hour flexibility, then you have maybe 15 hours per day.
And so all of these, it's all about trying to create a more liquid and a much more flexible market structure. That means the capacity of the reserve markets is much greater, so that whoever it is, a commercial business or a homeowner, can basically buy and also potentially sell electricity on a minute-by-minute basis.
At least on a 15-minute basis.
A 15-minute basis.
Yeah, we're transitioning to a 15-minute market from next year.
Okay.
How is this going to look for the consumer? What is this going to look like for them? Is it going to be as simple as connecting your car and your app and your charger one time, you set it up, and then you get a nice payment at the end of each month? Is it going to take a lot of research and deep knowledge of this, or is it going to be a nice, simple software solution that a driver can benefit from?
Like the simple use case of just tariff minimization, then any kind of app could do that, basically. But if you want to be part of the reserves, then it's a bit more complicated, where you need a market actor that has a communication with Energinet and pre-qualifies your asset, and there needs to be kind of a documentation and paper trail of your kind of technical specifications, and it needs to be traded into the market the day before, and market actor needs to be sure it's available. I mean, that is kind of what we are doing with EVs. It's not necessarily something people are going to notice, and it can all be happening in the background, but there needs to be someone who is kind of taking care of it.
So then the impact on the driver is, one, there is some sort of financial incentive on an annual basis by making sure that your vehicle is connected, your solar panels are connected, and you can essentially potentially earn a little bit of extra money. But it also sounds like what you're talking about is it's not necessarily a direct benefit.
I think we are going to move more into making a change that the driver can kind of see, because with the primary reserves, they don't even notice if the charger has been turned off for 30 seconds. But if you want to participate in the imbalance market and say to Energinet, I can actually turn off this huge portfolio if you really need it, or if you're willing to pay a premium, then when that happened, then the charging would be extended for 1 hour because it would be 1 hour delayed. Then they would also get the value of that flexibility. I think we're moving more into like kind of bigger, like flexibility on a longer time scale.
So to kind of wrap that up, so the no transition without transmission. So with Hybrid Greentech, with more V2G, we don't need transmission to be built out, or is there still a both case scenario here?
I think transmission capacity is probably the best investment you can make as a country at all. I mean, reducing your bottlenecks has a huge value for the green transition, because you will always have this problem. You have too much production on one side and too little on the other side. I'm a huge fan of transmission capacity. I actually live right next to one of these overhead lines, and I just appreciate them every day when I go to work.
Yeah.
Or they're helping it's the highway of the green electricity.
Yes, you are a yes in my backyard.
Exactly, I love it. I would have one more if...
You're a YIMBY, not a NIMBY.
Yeah.
But it's also because you have different problems. You have the congestion, that's kind of a very specific problem, and then you have the stability of the overall system. Where you cannot have the imbalances in more than a few seconds until you start having serious instability problems. But congestion is a very different problem. And then you have congestion on the high voltage level, where it's like from price zone to price zone or from Lolland to København. You can do something about activating some flexibility if you have some consumption in Lolland that you can activate in those hours, for example. But most likely, pretty soon, it's better to build some more transmission capacity because that problem is going to increase. Then you could say you have kind of the same problem on the low voltage grid, which is out where the residents are connected. The 400 volt grid, the last radial line taking it to the end customer. Those grids were like built 30, 40, 50 years ago without EVs in mind. And that's where you also start to be able to see some congestion. But for the consumption, just getting it to the end customer. Maybe it's fine to supply it on the overall system level, but getting it to the end customer can still be a problem if everyone wants to consume at the same time.
So could we maybe talk about the commercial aspect of this a little bit? About the business opportunities here in there for like the virtual power plant is like how Hybrid Greentech is making money in this space. And then a little bit like the race for connected assets and everything. Talk about some of the ways that the commercial relationships and interactions work in this space.
Yeah, so the primary reserves have been delivered by hydropower plants, mostly in the Nordics. But then when you start getting the green transition, you get super low prices sometimes, and then they don't want to be producing anything, and then they cannot regulate anything. So all of these primary reserve prices have increased a lot, and there's also been coming new markets. Like, for example, previously the worst thing that could happen was a nuclear power plant failure. So that's a loss of 1.4 gigawatt production. But then they have started building these high-voltage DC cables to the neighboring countries of also 1.4 gigawatt. And then suddenly you can also have a loss of consumption of 1.4 gigawatt. So you can have an equally big disturbance in the other direction. So now they also needed to buy disturbance reserves for loss of consumption, where you actually need backup consumption of people to consume when someone else is not consuming.
So you're saying, so the way that it's set up currently with different energy sources, renewable sources, changes in perhaps country strategy, this creates basically a much greater need for the balancing market and a much greater need for reserves. And then as a result, there is an opportunity for companies like Hybrid Greentech and then also Monta to offer whatever it is, a mechanism to support basically the transmission system operators and the distribution system operators balance, and then also bring the balancing market prices down as a result. Is that right?
Yeah, so what we develop is something we call multi-market optimization, where we have a battery, for example, and it has 5 different markets it can participate in. They have different prices, but they also have different costs. Some of them are activated a lot, and some are almost never activated. So you also have different costs for your or different expected battery degradation for being in the different markets. Basically, what we're doing is that we're looking at the optimal decision of markets to be in. So we might be in 5 different markets in 4 different hours, because we can deliver the disturbance reserve or the normal operation reserve, or we can optimize on spot prices or on imbalances or the fast frequency regulation reserve. There's a lot of opportunities and a lot of different value streams. And kind of to get the top value, you really need to compare all these opportunities, because some of them can be stacked and some of them are kind of exclusive and you cannot deliver it at the same time.
So the Hybrid Greentech commercial team, the sales team, who are they going out to pitch the product to or try to bring in as a customer? Who are the owners of these batteries and these solar plants and everything? And then you or somebody else from Hybrid Greentech goes out and says, look, let's work together on this, and we can take all this great power that you have, and we can do this, and then we do like a revenue share kind of thing. Is that what it is?
Yeah, usually. So it's only a one-way payment from us to the customer, and then we take a cut of that.
Right.
The customers would be asset owners. So sometimes it's someone who has a PV park, for example, wants to install a battery at the same place, or it's a greenfield, completely standalone battery, or often it's actually industrial customers like medium or large-scale industrial customers. Usually it's them reaching out to us and say, I'm exporting all this PV power to the grid, I'm not getting anything for it. It's like, yeah, sure, that we can help you with that, of course. And we kind of made this ESG optimization that makes sure that you have as green electricity for your facility as possible. But then at the same time, you have a battery with a lot of capacity that you can sell to the grid.
Wow. Wow.
Do these customers, do they realize this potential, or do you sometimes have to educate them about this a little bit? They're like, I've got solar panels, I got a battery, and then Hybrid Greentech comes in and says, did you know if you work with us, you can be contributing this and reduce that payback period for that whole site from 15 years to 5 years?
That can be a bit of a challenge because it's kind of a niche sector, and people are like, who's paying this money? Is it real money?
You're like, yes, it's real money. We'll send you the money, we promise.
Yeah, exactly. Yeah. Like you lost 10 million kroner by not working with us in the last year.
Yeah. You show them a chart that says, look, if you had made this available, we could have participated in this way, and you could see what
it's accumulating.
Yeah. But I think it's true. I think it's a huge opportunity to be a charge point operator, to operate fast charge points. They cost 100 to 150 grand to purchase and then install. Particularly now as utilization is somewhere between 5 and 15%, the payback period is 30, 50 years. We're talking a long time. And so if there's a model that exists where you can bring that down for charge point operators, but also for businesses, for companies that are set up as basically a BESS, so where they're just running battery services as well in reserves, it's a huge opportunity for them to bring that
There's
down.
actually another use case because a lot of these gas fueling stations around Denmark, they want to transition. And I think they thought they had a huge advantage because they have the best sites. They've been collecting the best sites for the last 50 years. And then they say, I want 1 megawatt capacity. And then the grid operator says, yeah, sure, in 3 to 4 years.
Yes.
But maybe they can get 200 kilowatt or something. And then they could put up a battery. And then the battery can handle the peak shaving in the peak hours. And then the battery is going to be idle for 80% of the time, except if you actually use it for selling capacity to Energinet.
Yeah. I was just looking and pointing at Kevin because Kevin's just come back from the US and has some conversations with operators out there and the types of models that they are using to kind of get around this. It's a problem that happens here in Spain. It takes almost 3 years to get the right amperage allocated. But with the US, they're taking a different model, which is much more about setting up batteries on site, right, Kim? I'm kind of looking over to you, right?
Because over there, the utilities are basically screwing over DC fast charging operators. They say, all right, if you have 10 chargers at a site and most of the time only maybe 2 to 4 are occupied, but when 10 come and then they have to pay for the power for the 10 at that peak, they call it like surge pricing basically, or demand pricing, then the utility says, because we have to keep this amount in reserve ready for your 10 charger site, we're going to charge you for that, even if that only happened once or twice in the month. So over there, we met a lot of these hardware manufacturers that are putting batteries in the charger or big batteries on site. They then trickle charge it throughout the day. And then, right, like you said, they handle the peak shaving and everything so that when there are 10 cars that show up to charge at the same time, they're pulling the power from the battery as opposed to having to call on the coal-fired generation plant, right?
But that is actually the same in Denmark. You need to pay for your maximum ampere, even though if you only use it once per year.
And how are operators working around that here?
There are some companies that makes a kind of combined DC charger and battery built in, and then some are putting batteries next to them on site. Yeah.
If we can prove the case with load balancing, we can say that your total amperage is required at this level.
You can get pretty far with load balancing.
Yeah.
In terms of reducing your cost and getting a faster grid connection.
So I think one thing that the discussion of a new kind of connected home with solar, PV, batteries,
Smart meters,
heat pumps, an electric vehicle, right? A lot of that is in the context of a single family home, right? And you're like, where you have a little bit more autonomy and more decision-making power over what goes on in your house. It's a little bit different dynamic, as we know. You have less autonomy over or decision-making over what's going on in your individual apartment and everything. So these benefits might seem far off. You're like, well, whether my building has a heat pump or not, or whether we have EV charging or not, or whatever, that's not really my problem. These benefits might not ever accrue to me or anything. So how do we design things or talk about these types of solutions and their importance to people that live in these multifamily units, apartment buildings, condos, and everything to make sure that they can also participate in this and push it forward, right? Because that needs to be transitioned as well.
Yeah, so there's this thing called energy communities, which is all about the idea of sharing electricity with your neighbors. But the problem is, when you have an electricity meter, then even though the power is flowing out of your apartment and into yours, then you're going to pay export tariffs and you're going to pay import tariffs, and you're not going to get any value out of that. If you have a house, an apartment building, then you can actually have PV on the roof, and then it's great to be many, because then it's more likely that someone will use the production, and it's not just going to the grid, and you have to pay a lot of tariffs.
Right.
And then in these setups, it would also be much, much cheaper to install a single battery in the basement, for example. If you have enough PV capacity that charge the excess production during the day and kind of optimize, maybe discharge to the apartments during high tariff hours, for example, or high spot price hours. Mm-hmm. But I think it's definitely a good case, and you can create a lot of value out of that setup.
Are building companies doing that?
Yeah. I mean, we're contacted by a lot of real estate companies that own offices, own apartment buildings. They want to have a business case of doing some kind of system. And there is actually also a really high value for the grid, because you could say it's nice to have these 50, 100 megawatt grid scale projects around. They can support the grid a lot, but usually getting that online will take like 3, 4, 5 years. So using the existing grid connections and increasing the utility of them is really a good way to increase the green transition, because the biggest problem of the grid companies is lack of hands.
And now Novo Nordisk is taking up every contractor in the country, is what I heard. So like all these, because they're investing like $10 billion in R&D and building out their factories to make sure that Ozempic and Wegovy get pumped out. And so now everybody falls to the back of the queue. So there's a mad scramble for people that can work with their hands in this country, right?
Exactly. It's not about the money, it's about getting it done physically.
Yeah.
Cool. So then, final question. We like to finish every podcast recording with this one. So, Andreas, if you were to bust one myth about the EV and the EV charging industry, what would it be?
I think a lot of people think that uncontrolled charging is going to melt the grid. I mean, a lot of the DSOs have been talking about this for 10 years and saying they need billions and billions of extra money, because if you want to be able to get these EVs. When I was at DTU, I did a lot of simulations, and previously the assumption was that everyone would come home at 6 and charge at the same time. And then it's true that an old 50-year-old grid would have an overload after maybe 40% of the households got an EV. But then I got access to all this telematics data from Nissan and could see, okay, the peak is never more than 18%, because people don't charge every day. And they charge it every second day, every third day. And then the first guys are done charging before the last guys come home and plug in. So actually the problem for the grid is all about the power peak, how many is charging at the same time. And that peak is actually pretty low for uncontrollable charging. But then as soon as you start doing smart charging, then you're going to charge when the electricity is cheapest, and everyone has the same electricity price. So then you actually squeeze in the coincidence or increase the coincidence factor. Smart charging is a much, much bigger problem for the distribution grid. And you can see it in a lot of areas around Sjælland and DK2, that in a lot of days, the peak is not at 6. It's not the cooking peak, it's the charging peak. The peak happens like 2 o'clock or 1 o'clock.
So it's not a peak shaving technique, it's a peak shifting technique.
Yeah, it's peak boosting.
So are you anti-smart charging?
No, I mean, you could say smart charge is like a two-edged sword. Smart charging will take us half the way. It will make problems worse, but it will also give us the tools to smoothen it out, because it's super easy technically to say, okay, I'm like distributing them over 4 hours or something like that. But then, of course, it's going to be a little bit more expensive, because who's going to pay out my customers to not charge in the cheapest hour? And that's where this DSO flexibility comes into play.
The myth is, it's vehicles are not going to break the grid. The other myth is smart charging is the solution to balancing out vehicle charging at certain periods. What is needed to be able to complete that picture is an incentive structure so that people don't always put their preferences to charge at the lowest price hour or period at 1 a.m. or so. There needs to be something else in place to mean that I'm willing to then charge at a time where it's slightly higher as opposed to lower, and I am compensated for that.
And that might not be what the overall grid needs. They usually don't have the same need, your local grid and your transmission grid. But so you can say that the EVs are going to solve the problem that they will cause.
Okay, so it all comes full circle in the end.
Yeah.
Fantastic.
They're going to cause some problems, but they'll solve it too.
Yeah, we hope.
Well, there is some randomized delay in some of the charging as well, right? So maybe
I noticed that, actually. Yeah. I was like, my charge is starting 17 minutes past 1 or something. I'm like, how can that be the optimal decision for me?
Yeah, exactly. There is a automatic randomized delay that's put in there, and that's also part of the UK.
Okay, but that's actually really good, because the worst thing is when they all start at the same time.
Yeah, exactly. Okay, great. Andreas, thank you so much for coming in and having the conversation with us. Really great to, hear your deep knowledge about the market structure and also what Hybrid Greentech are doing. Thank you.
Thanks a lot for having me.
Thank you.
Thanks for joining us for the latest episode of In Between Charges. As always, I'm Kevin Spangenberg, joined by Mike Hawks. Thanks for listening. If you liked what you heard, give us a rating on Spotify. Keep our perfect 5-star review going. If you didn't like it, please don't leave a review. You can follow us on LinkedIn, on Instagram, and we'd love to hear what you have to say. So we'll see you for our next episode. Thank you.